Let knowledge flow like a river without any hindrance. Don't make it like a stagnant pool.
Shear force and bending moment analysis of a beam under different load and support condition and introduction of new diagram. Part 2. Hello everyone, I am P.M. Chatterjee with you. Today I am going to explain you how we can calculate bending moment and shear force of a beam under different load and support condition in Excel by mu diagram. This is part 2, and you are going to watch for full and uniformly distributed load, that is U.D.L. If you are watching this video first time, please start from part 1 for more explanation. I hope you are going to enjoy this video. Minimum requirements for this: IS 456 2000, SP 1619X0, Excel software 2010 onward. Before start of the lecture, please like, share and subscribe my channel. Analysis of a beam with uniformly distributed load over full span. This is our beam, U.D.L, small w or meter length, and left hand side A, right hand side B, mid portion C, and length L. Bending pattern of a simply supported beam with uniformly distributed load. Bending pattern of a simply supported beam with uniformly distributed load will be like this. Load distribution on beam. Look here. Load on the left hand portion is a W, small w into L by 2. Total load W into L. On right hand side, W into L by 2. This green spot and this yellow spot are the CG of this half portion of the beam and this half portion of the beam. RA, the reaction at left hand support, is equal to W into L by 2, and RB, the reaction on the right hand side, is equal to W into L by 2. Shear force and bending moment for simply supported beam. The reaction on left hand support and right hand support is RA into RB is equal to W into L by 2. Shear force at left hand support DA is equal to RA is equal to W into L by 2. At right hand support BB is equal to RB is equal to W into L by 2. Shear force at mid span DC is equal to W into L minus W into L by 2. That is W into L by 2. Bending moment at left hand support is equal to right hand support is equal to 0. Load CG from left hand support and midpoint is equal to X, L by 4. Span moment at C is equal to RA into L by 2 plus W into L by 2 into L by 4. So, bending moment at center NC is equal to W into L by 2 into L by 2 plus WL square by 8 is equal to WL square by 4 plus WL square by 8. Finally, span moment MC is equal to minus WL square by 8. Shear force diagram for simply supported beam. Here RA is equal to W into L by 2, RB is equal to W into L by 2, and the center shear force will be 0. And this is also point of contraflexion. Point of contraflexion is that point where shear force changes its sign. bending moment diagram for simply supported beam. At right hand support, bending moment 0, left hand support 0, and mid span minus WL square by 8. Fixed end moment by mu diagram when load is full and uniformly distributed load. Fixed end beam with uniformly distributed load. Bending pattern of a fixed beam with uniformly distributed load will be like this. Mu diagram. This is actually mirror image of mu diagram. This is actually mirror image of simply supported bending moment WS square by 8, and area under this curve is mu. It's going to be 2/3 into L into WL square by 8. Mu dot is a diagram for fixed end moment. We know MA is equal to MB. Our area mu dot will be equal to L into MA. Superimposing of mu diagram for span moment. This X portion is common for fixed end moment and simply supported moment. And we have MFC is equal to span moment under fixed end condition. We know mu is equal to minus 2/3 into L into WL square by 8, and we also know mu plus mu dot is equal to 0. FEM at A is equal to MA and at B is equal to MB. MA is equal to MB. Mu dot is equal to MA into L. Again mu dot is equal to minus mu M into L is equal to 2/3 L into W into L square by 8. Therefore, MA is equal to 2/3 into 1/8 into WL square by 8. That is WL square by 12. So, finally we have fixed end moment at A and B is equal to MA and MB is equal to WL square by 12. Maximum span moment of the beam. Span moment will be maximum at center. So span moment at center is equal to MFC. MFC is equal to minus W into L square by 8 into WL square by 12. Is equal to minus WL square by 20. Finally, span moment at C is equal to MFC is equal to WL square by 24. Bending moment diagram for fixed end beam. MA is equal to WL square by 12, MB is equal to WL square by 12, and MFC is equal to WL square by 24. Support reaction and shear force. Say support reaction at A and B is equal to RA and RB. By taking the moment about B, RA into L plus MA plus MC plus MB is equal to 0. We know MB is equal to minus MA. RA is equal to RB and MC is equal to WL square by 12. Sorry, MC is equal to WL square by 2. RA is equal to RB is equal to MC by L is equal to W L square by 2 into 1 by L is equal to W into L by 2. Finally, reaction and SF at A and B and C are RA is equal to RB is equal to BA is equal to BB is equal to W into L by 2. BC is equal to RA minus W into L by 2 is equal to W into L by 2 minus W into L by 2 is equal to 0. Shear force diagram for fixed end beam with U.D.L. Deflection at the center of the fixed end beam with uniformly distributed load. Deflection of the fixed end beam at any section distance x from A, mx is equal to mu x minus mu dot x. Mx is equal to x into W into L by 2 minus W into x by 2 minus W square by 12. Mx is equal to E into I d2y dx2. This is differential equation that governs the beam behavior on the bending. E is equal to elastic modulus, I is equal to moment of inertia. Therefore, Mx is equal to E into I into d2y dx2 is equal to W into L into x by 2 minus W into x square by 2 minus W square by 12. By integrating this equation, we have EI into dy dx is equal to W into L into x square by 4 minus W into x cube by 6 minus W into L square by x divided by 12 plus C1. Number 1 equation. C1 constant of integration. When x is equal to 0, dy dx is equal to 0, therefore C1 is equal to 0. EI dy dx is equal to W into L into x square by 4 minus W into x cube by 6 minus W L square by x by W L square into x divided by 12. C 0. C1 0. Therefore, this is our equation 2. By integrating equation 2, we have EIY is equal to W into L into x cube by 12 minus W into x to the power 4 divided by 24 minus W square into x square divided by 24 plus C2. C2, once again, constant of integration. When x is equal to 0, dy dx is equal to 0, C2 is equal to 0. Therefore, E into I into Y is equal to W into L into x cube divided by 12 minus W into x to the power 4 divided by 24 minus W into L square into x square divided by 24. This is our equation number 3. Maximum deflection occurs at C, that is x is equal to L by 2. Substituting the value of x by L by 2, we have EIYC is equal to W into L by 12 into L cube by 2 cube minus W by 24 into L to the power 4 by 2 to the power 4 minus W into L square by 24 into L square by 2 to the power square. Or YIC is equal to W into the power 4 by 96 minus W into L to the power 4 divided by 384 minus W into L to the power 4 divided by 96. Or EI into Y says that W into the power 4 3 by W into L to the power 4 by 384. Negative sign indicating downward deflection. Finally, deflection at center of the fixed beam Y says equal to minus W into L to the power 4 by 384 EI. Now I'm switching over to the X spreadsheet for numerical calculation. Welcome to my Excel spreadsheet for the design and analysis of beam under different load and support conditions. Now I'm switching from point load to distributed load, and it is U.D.L. Look here, we have a question mark here, check. Why? Because it is we do not require the value of A. It will be 0. Now we can change if we change 10 to 100. Deflection 0.058. Reaction and moment for simply supported beam. Left hand support 300, right hand support 300 kilonewton, span moment 450 kilonewton meter, fixed end beam moment, left hand support 300 kilonewton meter, right hand support 300 kilonewton meter, span moment 150 kilonewton meter. One thing we have to keep in our mind that span moment of a fixed beam is half of the support moment. Maximum shear force left hand support 300 and right hand support 300 kilonewton meter. And for U.D.L, this shear force is same as simply supported beam, 300. Deflection of the beam under fixed end condition 0.00580 mm. L by D ratio 1,35,270. It is good enough. If we change this 250, it is 1,09,402. 1,29,402. And this is our data sheet. This is our input and result.
Yes, you are the right person to me, whom I can request. Don't worry, I'm not asking any money from you. Since you are watching this video till now, yes, you are the connoisseur of the structural design and analysis. I have a request to you. I'm asking more organic watching hour from you. Only you have the veto power to add the organic watching hour to my channel. You may think, how can you do this? You can do this by taking the following action. By providing more time in my channel, by sharing the link of my channel, by making regular comment and providing like, by any measure that you know but I don't know. I can assure you that your investment will provide you the dividend in near future.
How to collect your free Excel sheet. You can request for any Excel sheet that I have explained in my channel absolutely free of cost. To get any Excel sheet, you have to follow this. Number 1, not more than one sheet per month. Number 2, first you have to write in the comment section of YouTube name of the sheet only. About you, student or professional like that. For which country and place. Then mail me. My mailing address is pranavchatterjee622@gmail.com. After receiving the mail, send me the acknowledgement through YouTube comment section, not through mail. After using, give me the feedback through YouTube comment section only. After getting the file, instead of redistributing among the friends, share the link of my channel. In the bending moment and shear force of a beam under different load and support conditions next part 2. I hope you enjoyed it. Please don't forget to subscribe my channel. Thank you.